Okay, good morning, everyone. Am I audible? Am I audible? Please confirm me.
Yes, sir.
Okay, just wait. I am. Okay, so very good morning, all of you. So we have discussed in our last classes. This is the strain gauge system. Okay, and last classes we have to also started the principle of operations and basic knowledge of the strain gauge system. What is the principal operation of this resistance size of strain gauge, and what is the basic application area, or something is the stress and strain, what is the young modulus. So these topics we have to cover in our class. So at the ending of the class, we have to discuss this is the operating principle of the resistance strain. Okay. So last equations we have to draw for the small variation for small variation expression can also be written as these equations we have to draw. That is the last class. So please, those who have not present in the previous class, so please go to the video, the previous video. Okay. So this is the del R by R. You know that this is the del L by L minus. This is also del A by A, and also another one del rho by rho. So this is the equation number we have to given here, equation number 1. So this is the basically expressions for the small variation we have to measure using the strain gauge method. So this is the basically equations. Now you know that under strain condition, cross-sectional area of the conductor change so the diameter of the conductor is also changed. Also changed. So here the area is the A. Area is that is A is equal to, you know, that is 5 by 4 RD square. Okay. Now you have to derivative with respect to the dbs, that is surface area. Okay. So we express here delta A to delta S. This is equal to 2U2 into 5 by 4. This is the D of delta T versus delta S. Okay, so we have to derivative if this equation that is the area is equal to A is equal to pi by 4 b square. This expression is given this part. Now dividing both sides of above expression, this expression, above expression by A. Okay. So now we have to dividing these expressions for the expression by the A. So now the equation is given, that is 1 by A dot del A by del S, which is equal to 2 pi by 4 into D, that is del D by del S. Another one, this is A, but here A is equal to, we know that pi by 4 B square. So that's why we have to written here, that is pi by 4 B square. Okay, is it okay, all of you? This is the equation number
Yes, sir.
2. So next, for small variation, expression, that is previous expression, that is equation number 2, expression 2, can be written as this is the delta A by A, which is equal to 2 into AT by. So this expression for the any small diameter or any small variation is changes to the strain curve. Okay, so this is the del A by A is equal to 2 into AB by T. Now you have to know the change in diameter of wear. That means we have to change the diameter of wear. Okay, so now change in diameter of wear can be related with change in length of wear by the Poisson's ratio. By the Poisson's ratio. So here one question is another. What is Poisson's ratio? This is another short question. Poisson's ratio. This is expressed, that is mu, okay, of the wear material as given below. So this is the expression, that is delta D by D. This is equal to a mu into del L by L. This is the another equation 4. Okay, so here mu is the basically Poisson's ratio. So what is Poisson's ratio? I am given for descriptions. Poisson's ratio. So Poisson's ratio, it is basically related in our elastic material. You know that every material, it has a particular elastic limit. I am given previous example, that is a rubber. You have to extended the area of the rubber, it is maximum level of the extended, then once upon a time this extended version is too much excess, then the rubber is broken or tear. So that like rubber or any material, steel, nickel, chromium, aluminum, etc. So this has a basically want elastic material. So this elastic material or an elastic material, the Poisson's ratio that is mu is defined as the ratio of strain lateral strain to the longitudinal strain. Okay, so this is basically a ratio between the lateral strain to the longitudinal strain. So that means the equation is mu is equal to, we express that is lateral strain to the longitudinal strain. So please remember this definitions. This is very much important for this Poisson's ratio. एग्जाम में आ सकते हैं what is the definition of Poisson ratio. अभी आपको ये लिखना पड़ेगा. So Poisson ratio, it is the ratio between ratio of the any elastic material, okay, ratio of the between lateral strain to the longitudinal strain also, okay, and it is expressed as that is mu. Okay, so that's why we have to express here. This is the basically change of the diameter anywhere. It can be related with the change of the length by where? By the Poisson's ratio. So this is delta d by g. This is equals to minus of mu del L by. So now come to the point. So moreover material, basically the diameter is changes, that is small variation, more or less that is 0.3, that is 0 to 0.5 is maximum, but averagely we have to take that is 0.3. Okay, so value of mu, that means the Poisson's ratio, is approximately 0.3 for most of the material. Okay, so this is the basically average part. Its ranges is, please remember, 0 to 0.5. So I am we are take the average, that is 0.5. Most of the material. So now the expression, previous expression from expression, that is equation number, previous one expression number 3 and 4. Okay, please remember 3 and 4. And 4, we have that is also del A by A. This is equal to 2 into mu, that is delta L by L. So this is the another equation, equation number 5. So we have to express this equation 3 and equation 4. We have to put the value of the this delta D, these two equations. Okay, this equation 3 and equation 4 we have to expression here. So we have to written here delta A by A minus 2 mu, this is equal to delta D by D, that is delta L by A. Okay. So this is also delta. Okay, this is not A. This is delta. Change of diameter. Delta d by d. Okay? Now, so equation number 5. Substituting delta A by A, which is equal to minus 2 mu delta L by L in expression previous one, that is equation number 1. We get. So previous equation number क्या था? So this is the equation number del R by R equal to delta L by L minus delta A by A plus delta rho by rho. So now we have to substitute in this value delta A by A is 1. So the equation is remaining, that is that delta R by R, this is equal to delta L by L plus 2 into mu delta L by L, this one plus this is delta rho by rho. Okay, so we put the value of this one into the equation number 1. The equation 1, it is coming this part. Or now we have to divide both sides delta L by L. Okay, both sides we have to divide delta L by L. So equation is coming, that is delta R by R divided by delta L by L. This is equal to, we have to divide delta L by L, that is it is cutting down, that is 1 is coming, plus this one is also cutting down, that is 2 into mu, plus another one, this one, that is delta rho by rho divided by delta L by L. Okay, so this delta R by R by delta L by L, it is basically called the Gauge factor. Okay, so I am written here, this is basically called the Gauge factor, and G is the basically ratio of delta R by R by delta L by L. So this gauge factor, that is G, it is basically indicates the strain sensitivity of the gauge in terms of the change of the resistance per unit resistance or per unit strain. Okay, so I'm written here the gauge factor. It is another important question. What is gauge factor? Okay, so please remember the gauge factor, that is expressed here capital G, indicates the strain sensitivity of the gauge in terms of the change in resistance per unit resistance per unit strain per unit strain. Okay, so the gauge factor can be written as so हम लोग लिख सकते हैं ऐसे, that is G is equal to, that delta R by R by delta L by L, and it is the expression, you know, that is 1 plus 2 mu plus del rho by rho. This is the another equation. Equation number क्या होगा? Previous क्या हुआ था? This is 5. So this is the equation number 6. So I am written here. So this is the basically change in resistance due to change in length. This one, this is for this one. This is the change in resistance due to change in area. Due to change in area. Another one, this is the change in resistance due to piezoresistive effect. Piezoresistive effect. Okay. Is it clear, all of you?
Yes, sir.
So that means the strain here in the previous equation, strain, it is changes, that is, you know, delta L by L. So it can be measured in terms of Gauge factor. That is also G. G and delta R by R. Another one is strain. We have to express, that is delta L by L. This is equal to epsilon. So it is basically measured in micro strain. The range is 1 micro millimeter per meter. So this is the small diameter any changes. Okay. So this is the basically Gauge factor expressions. So please remember this expression. This is very much important. How it is calculated from the previous one. Okay. Is it clear, all of you?
Yes, sir.
Now, next point. What is the basic classifications of the strain gauge system? The first class we have to discuss. Basically, this strain gauge, it is applied area. We have to classify it into different categories. That is mechanical gauge. You know that optical strain gauge. Okay, resistance. That is the electrical strain gauge. So these are the basically application area oriented. We have to classifications of the strain gauge. But in our particular electrical resistance strain gauge, you have to classify it into another category. So I am written here. This is the classification of strain gauge. So this is basically classified into two categories. First one is the bonded type, and number two, unbonded type. So these are the basically bonded and unbonded. It is basically coming from the where strain gauge. Please remember, this is called the where strain gauge. This is number one. Another one, foil strain gauge, number B. Foil strain gauge. Okay. Number C, another one, fine wear strain gauge. These are same, fine wear and wear strain gauge. These are same categories. C, metal foil. Metal foil strain gauge. Number E, thin film strain gauge. Number F, that is semiconductor strain gauge. And last one, that is photoelectric strain gauge. So these are the different classifications of the strain gauge method. So these are basically broadly classified into the electrical resistance type of strain gauge method. Okay, so first we have to classify that is wear strain gauge. It is also classified another two categories, bonded type and unbonded type. Number two, foil strain gauge. Number three, fine wear strain gauge. Number four, metal foil strain gauge. Number five, thin film strain gauge. Number six, semiconductor strain gauge. And last one, photoelectric strain gauge. So these are the different categories we have to classify the strain gauge. So there are the some advantage and disadvantages also available. Some of them. So first of all, we have to basically uses mostly in our industrial purposes wear strain gauge, because this is a basically smaller in size. Okay, whatever you have to use it in any places, that is a smaller in size. So it has a minimum level of the leakage. Okay, and it is also high temperature application. So these are the basically I'm written here. This is smaller size. Number two, this is the minimum leakage. And number third, it is basically high temperature applications. So that's why we have to use this mostly in our industry oriented strain gauge. This is a wear strain gauge. Okay, is it clear, all of you?
Yes, sir.
So in your book, these are the basically details part. It is available. So everyone, please see the details. Different types, foil strain gauge or thin film strain gauge. These are the some of theory available. Little bit, not a difficult limitations. Now another point. It is very much important. What type of material? Okay, what type of material you have to use for making the strain gauge systems. Okay, so I am given the one idea. So more or less we have to use this first one, material uses for strain gauge. Number one, we have to use this one advanced alloy, that is, it is called advanced alloy. This is made of 55% of copper and 45% of nickel. Okay, so this is the basically one advanced alloy, and sometimes it is also called constant ton. Constant ton or advanced type of alloy. This is made two material, 55% of copper and 45% nickel material available. Another one, it is made for nichrome. You know the nichrome? All of you listen. This nichrome, it is made 80% of nickel. Ni for nickel, you know that, and 20% of chromium, Ch for the chromium. Okay, so this is the basically nichrome type of material where 80% of nickel and 20% of chromium. Another one, ISO elastic type of material we have to use this. ISO elastic, here are 36% of nickel, 8% of the chromium, 4% of manganese, and silicon and molybdenum, and 52% is the iron. Okay, so this is the basically ISO elastic type of material. Most of the industrial purpose we have to use this easily access, that is the ISO elastic type material. This is made 36% nickel, 8% chromium, 4% of the manganese, silicon, molybdenum material, and rest of the amount 52% is the iron material. Another it is basically costly material we have to use is, you know, platinum. This is very much costly. Okay, platinum, and it is a pure format, that is 100% of platinum uses. Okay, and another one, it is also made nickel. It is also pure type of material you have to use it. That's why this is a basically costly. So we have to use this in frequently, or any advanced level of instrument we have to use this platinum and nickel. Another one is alloy. One alloy it is used, it is alloy 479. This is the material name, alloy 479. Here the 92% platinum and 8% of W. What is W? W is wolframite. Wolframite is the one another material. So these are the basically different material we have to use this for the strain gauge system. Clear? Is it clear, all of you? So
Yes.
now the basically particular applications. Next part. So in your book, some of problems are available. That is HS1E or JB Gupta. Both two books are very good. Okay. So whatever you have to follow these two books. So here the strain gauge different examples are available. So please everyone practice the small type of problems. That is stress and strain calculations. That is Poisson's ratio calculation. What is the Young modulus calculation? So these are the some small type of problems you have to practice. Okay. So now the applications of the strain gauge. So basically you know that this strain gauge it is transducer. It is basically uses for the analyzing and dynamic stress of the complex structures. So first one, strain gauge transducer are extensively used. Everyone write your own name and roll number in the chat box. Extensively used for analyzing the dynamic strain in complex structure. That means where that is such as the stress and strain in bridge, automobile sector, roads, etc. Okay, so this is a basically applications area broadly in our country. You have to use this. These strain gauge transducer are extensively used for the analyzing the dynamic strain in complex structure. That is the stress measurement for the bridge. Sometimes it is also used as automobile sector and also roads. Okay, next number 2. This strain gauge transducer are used for measuring tension, another force measurement, stress measurement, that is stresses in structure also. Structures. Okay, so these are the basically application area using the strain gauge method. You have to easily measure the tension of the material, force of the basically system force measurement, and stresses in structures. So what type of material you have to use this in any material structure. So you have to easily experiment using this strain gauge method. And this it is also used. Rahul present, regular student Rahul. Rahul, regular student Rahul is present. Muskan is present.
No, sir.
Okay.